Question number 2 asks, find the equation of the perpendicular bisector of the segment joining point P at -2, -4, and point Q at 8 and -8. Now, I've gone ahead and graphed out the segment here with the 2 points, and I recommend that you use some graph paper for this one because it gets kind of messy. The first thing we're going to want to do is derive the function of the segment that we're given. And in order to do that, we're going to first need to find the slope of it by using the equation y2 minus y1 over x2 minus x1. Our y2 value is -8, and our y1 value is -4. Our x2 value is +8, and our x1 value is -2. Put all that together, you get -8 plus 4, which is -4, over 8 plus 2, which is 10. This simplifies to -2/5. This is going to be our m value in our formula. Y equals m -2/5 x plus b. We are yet to derive our b value, but this is how we are going to do it. Take our parent function and plug in one of the points and then compare that to the y value of what it is when b is applied, and that will give us our b value once we find the difference. So, let's start off by using one of our x points, 8, to begin this. Y equals -2/5 times 8. -2 times 8 is -16. Put that over 5. When we plug in 8 to our parent function, we are given the output of -16/5. When the full function is applied, we are instead given -8 equals y. Now we need to find the difference between the two by doing -8 minus -16/5. Let's give this a common denominator. So instead we have -40/5 plus 16/5 equals -24/5. This is our b value. Now we have the full equation of the line on which the segment of which we are given is on. And that is y equals -2/5 x minus 24/5. To get the slope of our perpendicular bisector, all we need to do is take the slope of our original function and give the negative reciprocal of that. Y equals 5/2 x plus b. Our b value is yet to be derived, but this is how we will do it. If we take our original graph of our original segment and we find the midpoint of that, we now have a point that is on both lines, and we can use that point to derive our b value. Let's find the midpoint. Our midpoint will be between our 2 points, exactly halfway, both horizontally and vertically. Let's take a look at it vertically. The central line between the 2 lines in which our points lay can be identified as y equals -6. Let's take a look at it horizontally. Between the 2 lines on which our 2 points lay horizontally, the central line can be identified as x equals 3. These 2 points together as a coordinate will give us our midpoint of our segment. The coordinate identifying the midpoint of our segment is 3, -6. Keep in mind that this point is on both lines, and we will use it to identify the b value of our perpendicular bisector. We will now use the same concept as we did before by using a translation of the parent function to give us the difference, which will be our b value. Our midpoint, which is on both lines, including our second one, is 3, -6. Let's plug in the x value to our parent function of y equals 5/2 x. When we plug in our x value, we are given y equals 15/2. This differs greatly from the output once b is applied, which is -6. Let's find the difference numerically, which will be our b value. -6 minus 15/2 equals b. Let's give this a common denominator. Negative 12 halves minus 15 halves equals negative 27 halves, which is our b value. Once we plug in our b value, we are given our complete formula for the perpendicular bisector of the segment on which our 2 points lay. The formula is y equals 52x minus 27